bioplastics, biosourced, biodegradable. People are really confused about all these kind of like words. Yeah. But more or less, you know that it's some sort of kind of like chemistry company that is kind of like branding a little bit better of a process or a material, but it doesn't give you confidence that it's the kind of stuff that you can literally eat. And by proposing something that was directly food, I think people really got that if you can eat it, nature can eat it. It's really biodegradable in the sense that people understand. And so at the beginning, the prototypes were...
I've been a big fan of Notpla for I don't even know how many years now. It's like 6 or 7 years now. And Notpla is basically this seaweed-based gel that can house liquid. But as we were talking in this Clubhouse group, somebody raises their hand and they want to get on stage, they want to talk. So he gets up on stage and it's Pierre, and Pierre's like, "Oh, thanks for talking about Notpla. I'm the CEO." And it's amazing how social media is allowing, just this access to just different people in different groups, man. So thank you so much for being on, Pierre.
No worries. And thanks for having me, and really love the serendipity of, one day walking back from the office, jumping on Clubhouse, seeing that there is a room around sustainable packaging. I was like, gotta jump in and hear what people are sharing and what people are talking about. And so small world.
Yeah, it was insane, man. Insane how that happens. So for anybody that's not familiar with Notpla, can you tell us a little bit about who you are and what you guys do?
Sure. So we're a sustainable packaging startup based in London. And we started a few years ago out of Imperial College, where I was studying a Master's of Innovation Design Engineering with my co-founder, Rodrigo. Before that, personally, I was actually initially trained as a mechanical engineer, and then I went on to work as a packaging engineer for L'Oreal. So I was in cosmetics and making lots of plastic shampoo bottles and cream jars and all these things, and kind of realizing that we make these things super fast. You see them flying on the conditioning line, but they've got to go somewhere. And I think that after a couple of years, I realized that I wanted to find a role that had a little bit more purpose and feeling like you were on the side of the solutions. And so we actually started the project. It was really kind of like a self-driven exploration, thinking of how we could make packaging that would be a bit more like fruits than containers, industrial containers, and taking a few kind of cues from nature. And none of us knew anything about seaweed or biology or most natural materials, but we just started by looking at things that were already existing out there in either the food industry or kind of culinary techniques. And we just ordered a bunch of different kind of ingredients and extracts and so on. And we were working out of our kitchen, and our flatmates were definitely finding it super weird that we were making a mess with all these kind of starches and tapioca seeds and hydrogels and cellulose and all sorts of different stuff. And one of the things that got us quite excited is a number of different seaweed extracts that are used in food techniques for making, for example, fake caviar, the spherification technique. And that kind of got us started on this experiment of trying to enlarge the little bubbles of caviar, because essentially, even if it was a food, it was kind of like a membrane that was encapsulating a little bit of fish-flavored water. And at that point, after a number of kind of prototypes, we started making slightly bigger kind of tomato-sized bubbles that were transparent. It was kind of an interesting thing, this seaweed extract was transparent. And also, you could contain a number of different liquids. And the cool thing is that because we were making everything in our kitchen and everything was an ingredient that was for food, it was actually edible. And so we made a video that was kind of running through the process for making these at home, what kind of powder to kind of buy on Alibaba and so on, and kind of put it out there, seeing if people would find it interesting. And I think the fact that it was packaging that was edible really got people, because there is a lot of bioplastics, biosourced, biodegradable. People are really confused about all these kind of words. Yeah. But more or less, you know that it's some sort of kind of chemistry company that is kind of branding a little bit better of a process or a material, but it doesn't give you confidence that it's the kind of stuff that you can literally eat. And by proposing something that was directly food, like I think people really got that if you can eat it, nature can eat it. It's really biodegradable in the sense that people understand. And so at the beginning, the prototypes were like very fragile and it was kind of like very early stage, but it got enough traction that we realized that there was something exciting to do because people were really waiting for an alternative. And we knew that it wasn't the Amcor and Tetra Paks of this world that were going to bring these kind of innovations. We all almost kind of like felt a bit of responsibility to give it a shot. And so we started a startup, started working with chemists and chemical engineers on improving the material properties and started to develop this product, which we call OHO, these bubbles, particularly for places of instant consumption. And I think it's
so how long? So how long from when you were in your kitchen to this point where you're bringing in, more mass production?
So like we got started. The project got started in 2014. So we've been running for about 7 years now. We had like the first couple of years we were literally kind of like working from the incubator of the university with no resources. We were not paying ourselves. It was kind of like a rough patch. And also we were not starting a business as businessmen. We didn't know, like we hadn't done an MBA or whatever it is. So we kind of like learned it the hard way. So we really kind of like jumped at this, like driven by the project and the product. So it took us a couple of years to kind of like figure out the plan and how we were going to kind of like drive this. And then in 2017 was when there was really kind of like the momentum got started. We did a first fundraise. It was an equity crowdfunding campaign. So it was, again, like quite democratic, a bit like the videos that got us started on the project. It was kind of like people from the internet funding this project because they wanted to see it become reality. And it was really exciting. We got £850,000. So that's like $1 million in just 3 days. And from 900 people all around the world. So it was super exciting to see that people were really kind of like putting their dollars against the project. And from there, we started to kind of like work on developing the machines, growing the team, and moving out to get our own space dedicated for this with like chemistry, engineering, design, biz dev, production, etc. At the moment, we are just reaching the point where we are 27 people, and we have a couple of other kind of like product lines that have kind of like sprung from the initial OHO product. So OHO was really focused on instant consumption, so things like marathons, festivals with like cocktails and so on. And also we've done a lot on like takeaway for like sauces like ketchup, mayo, because those places of instant consumption are the worst place to use plastic. Because typically it's going to get used in such a short time and plastic is going to stay around forever. So that's this kind of gap between how quickly the use case is and how long the material is lasting that we're trying to bridge. And then from there, we kind of like started to work on a couple of other applications, which is a coating for cardboard and flexible films.
So before we get into the coating and the flexible, then I think you kicked this off at school. It was a school project, right? Yeah. And then you're working in your kitchen. And as you're working in your kitchen, you're testing out all these different products. Of course, all the products are edible. And ultimately, you've got this transparent sphere that can contain a liquid. You go from there to going into mass production, at least bringing in more equipment, more chemists, making this product. Still, it's edible, but was there a flavor to it?
Yeah. So actually, you're right, because we really started with essentially like food ingredients, and we worked for years to kind of like bring it from the food world to the packaging world, because at the end of the day, the goal is to protect the content, deliver it, do its job, and then disappear as quickly as possible. And so a lot of the work was exactly on those points, like how do we make like a packaging that is not going to have a flavor on the content. So we worked a lot on the whole kind of like seaweed extraction, so that from the seaweed that you can imagine has a very kind of like strong like sea smell and flavor and so on, you get to something that is that doesn't have any kind of like residual color or smell. So that took a lot of time, a lot of kind of like efforts from chemistry, but also working with different partners, people who are directly seaweed farmers, people who are working in like extraction and so on, so that we could really drive this from like a from a food product to a packaging grade kind of like formulation, and equally with like the other parameters that are important, such as strength and barrier properties and so on. So all of this is kind of like, I would say, is continually improving. And one of the things we were talking on Clubhouse is that plastic has like 70 years of investment from all universities and governments and corporates to make it the amazing material that it is right now. And with a lot of other kind of like natural alternatives, we are starting at the very, very beginning of that journey. So what we're able to do right now is still quite limited from what we could be doing in 10 years. So I'm quite excited to see how far we're going to get.
No, I love that point, right? Plastic has all this history and all this money behind it. You're just getting started. Yeah. So you have just a tremendous amount of runway. All right, let's take a quick second to talk about idpdirect.com. Go right to that website, download the design guides, the sustainability guides, the recyclable icon guide, which basically lists out all the different icons. It gives them to you in vectors. You can drop them right into your artwork right now, today, and go right into production. All right, back to the pod. I remember when I saw this, when you launched Ojo, which was the first iteration of this product. It just looked like a Ziploc bag. When you look at it, it looked like a plastic bag with water in it, but it was this seaweed gel. And I think it was there was a marathon, and it was filled with like Gatorade or some kind of orange liquid. And of course, I spent a lot of time in food. And the first thing that I thought of was, do I want to be running and then have somebody hand me this ball with their sweaty hand, and then I'm going to eat it. So, there's the idea of transferring this package from one person to another, and just cross-contaminating. So even with the Ojo product, you'd still have to package that into something else.
Yeah.
Right. This wouldn't be able to transport in and of itself.
That's correct. And the actual applications that we target, they are places of almost instant consumption. And they are the places where we think that we can really remove single-use plastic by having Ojo, but also the supporting kind of like infrastructure for this. And so, for example, for marathons, we also have secondary packaging, which is essentially like big reusable containers that have like 300 units that the volunteers are taking the Ojos from as they deliver them to the runners. And we really had to kind of like work our way up in terms of logistics to pull that off. And I think that for us, it was quite an exciting kind of like partnership that we had in this case with Lucozade, which makes the energy drink, because we had to kind of like build confidence that this is something that was working on all aspects, on hygiene, on logistics, on delivery, on delightful kind of like experience for the runners, all of these things. So we really had a step-by-step approach, and we literally started with the smallest kind of like running events, no PR, completely kind of like under the radar, where we had like a couple of 100 runners, and we were just testing, A/B testing different sizes and different kind of like handling methods and so on. And seeing the things that were working well, we kind of like moved gradually from like bigger events to bigger events, up to the point where we got all the way to the London Marathon in 2019, which was the last one that happened.
Sure.
We were supposed to do even more kind of like even bigger kind of like production for the one last year, but it has been postponed to the end of this year.
Sure.
But we're still basically like lined up for making that happen. And obviously COVID has kind of like brought in a completely new perspective on all of this. So we were really working with London Marathon and with Lucozade and with, in general, all the different partners to deliver this in the best possible way. But in the London Marathon, everything was handled with gloves, and there was, as I said, like a lot of kind of like steps to validate the process to which we can deliver this, which was interesting because also I think the way we've been kind of like bringing this product is trying as much as possible to copy fruits and nature, and fruits work quite well. Like they've been around for
they work amazing.
And they kind of like have this relatively short shelf life, but like they're still kind of like taking care of themselves quite well. So we're trying to see how by making something that is a little bit like a fruit, we can use that natural cycle that works quite well and kind of like solve things that way.
Okay. And when you're talking about, fruit being, degrading quickly, or not necessarily quickly, but just degrading and having that as a natural property with the Oho gel balls, essentially, right? Because they all have to be spheres. Any angles, nature doesn't like an angle. So when we're talking about these spheres, like how thick is this material? And when you're going to bite it to consume the liquids inside, is it something that like splashes out? Is it like an orange peel? Like how thick, and what's that experience? Because I think of like mochi, the Japanese mochi on ice cream, where it's kind of like a fleshy texture. Yeah. What is this texture like, and how does it work?
So it's quite interesting because it's actually something that we can control to a certain extent based on the application. With the ohos that are kind of like meant to be consumed, and the main use case where people are like 95% of the time consuming the whole thing is for cocktails, because it really is the thing you kind of like pop. You have an espresso martini or a tequila sunrise like shot exploding in your mouth, and it's quite fun and surprising.
So you're not holding it. So you're not holding it like an orange and taking a bite and drinking it. You're popping the whole thing in your mouth,
like a cherry tomato. Yeah,
got it.
You like literally like put it on your cheek, kind of explodes. People are kind of like always making a very surprise face, so it works very well for Instagram. Yeah. And basically in that case, we've really kind of like made the membrane as thin as like steel does the job in terms of mechanical properties, to have the least kind of like chewing and the least kind of like presence in your mouth of like the residual membrane. Whereas on the other end, you've got the sauces like ketchup, mayo, etc., where you're never going to eat the packaging that like still has a bit of ketchup on it. So in that case, we can make the material a bit thicker so that it's a bit more resistant. So that's something that we can control. But yeah, the thickness is not as thick as a mochi, but like it can be like a couple of millimeters thick if we need to. But we're also trying to find the right kind of the right size for the job, because obviously we don't want to overuse material if we can just do the job. So it really tends to be like those kind of like two cases. If you're gonna eat it, we try to really make the nice experience of eating it and thinner. And if it's going to be like not eaten, then we can make it a bit thicker.
Okay. So if a brand is looking to partner with Notpla and create a new product for themselves, new packaging for themselves, then you're able to identify what the product is, obviously, but then also dictate the thickness and the experience. So it's not, you don't have just this 2 millimeter thick material and then that's all you're using. You customize it to the experience.
Yeah, absolutely. And we obviously have a kind of like a bit of a head start on knowing what works and what doesn't. So we are able to advise on like what would be the best experience. But we have been able in the past with certain clients that were coming with like very specific requirements, but also like sizable kind of like commercial opportunities that we would develop a little bit of like a specific solution to them to make something that like can fit their requirements. If they want like specific like added flavor or different things that can be like added to make the experience a little bit more interesting to them.
Okay. Yeah, that was one of the things we talked about on Clubhouse was, I've been talking to a few different restaurants and it always goes to, well, we have our own sauces. And it's like, okay, well, great. You should talk to Notpla because they have, you can buy the equipment and you can pack your own sauces in this material that is biodegradable, it's edible. And, if you're going to do this at a large enough quantity, then it'd be amazing if you could talk directly to the Notpla team and see if you can, change the flavor of that piece, right? So if you've got, say, a hot sauce, maybe the material that you're biting into to tear into has a little bit of spice or it has a little bit of sweet, something that's going to contrast that flavor to create a broader experience instead of just, a plastic container that you lift the lid and it's just boring, right? It's like create something that's amazing. Yeah. And everybody's so excited, but I'm still not seeing enough of this out in the market, right? So how does, so if somebody say in the US that wanted to purchase some of this product, what's the lifespan of this thing? When you pack it out in London and ship it, how long does it last before it starts breaking down?
Yeah. So, and it's a nice cue to talk a bit about the manufacturing of ohos. So basically, when we started developing this material for optimizing this material for making ohos, we tried to look for like an existing manufacturing technology that would allow us to move away from making everything kind of like 100% manually. But we didn't find something that was already kind of like existing out there that would be like applicable to the manufacturing process that we were using, because the material has quite a different kind of like behavior than plastic. It's actually heat resistant, so it's not heat sealable for the OHO product. And so it meant that we actually had to develop our own manufacturing capacity. So we built our own machines, and we kind of like developed a proposition that would be really like bringing both the enabling equipment and the material for people to start packaging their own products and stop using plastic. And so by developing our own machine, it's been like both like a great opportunity to make this technology kind of like available, but also like the challenge of developing a machine, making it reliable, kind of like scaling up the manufacturing kind of like supply chain and so on. And so the model we've taken is to have actually smaller machines that don't have a very big output, but that can be placed relatively locally as a hub model rather than like a giant factory that produces for the whole world. And what this enables us to do is to use materials that have a much shorter kind of like shelf life. And actually what we found out is that seaweed has a very, very kind of like easy time biodegrading in pretty much any environment, either like land-based or marine-based. It can break down as quickly as like a few weeks, which is great because it literally doesn't kind of like leave any trace. And it's again biodegradable in the sense of like fruit peels rather than PLA and like bioplastics. But it also means that you have this challenge of needing to produce and then bring things to like to the point of consumption. And so by having these smaller machines that can operate locally, that's how we bridge the gap between those materials that are very biodegradable and the places of consumption. So all of this to say that at the moment, we only have machines in the UK. We're still at the stage of kind of like growing the capacity in terms of making more machines and bringing them to other territories. And we are really excited to bring it to the US because the market is big and we are really kind of like keen to bring the innovation there. We have a couple of investors based in the US. So we were actually planning on making a first hub in the US in 2020, but COVID happened.
Yeah.
But yeah, I think that that's definitely something that we have in the pipeline. And it would be as simple as bringing like one of our machines and shipping some of our kind of cartridges of seaweed material, and we could get started in producing. But it means that it's not really possible to ship things directly from London and hope that you have enough time to sell them before things start to kind of like go off, because the shelf life it really depends on what you encapsulate, but it's from like a few weeks to a few months. For some products, it's even just a few days. Like we did a collaboration with Tropicana from PepsiCo, one of the oranges brand, for one of their cold pressed juice, and literally the product had a 4-day shelf life. So that was like on the shorter side of things.
Wow.
So
a 4-day shelf life. What happens on that 4th day? Like, does it just dissolve and just spills, or like how does that?
So it doesn't, and it actually doesn't like break down physically for a while. Shelf life is mainly driven by microbiology at this stage, and because the membrane is kind of like ready for nature to kind of like recycle and like turn into compost, like as soon as you have the presence of microorganisms and enough moisture levels and like the availability of air and so on, there is a chance for this process to start. Just like a fruit, after a few months, if you kind of like leave it in a very moist environment, it's going to start to rot and you're going to start to have the biodegradation kick in. So at the moment, the shelf life is mainly driven by the acceptable level of microbial activity that we set. Usually it's case by case by a company that has like certain level that is acceptable to them. So that's how we usually kind of like agree to set the shelf life. In the case of this orange juice, the level that was set by PepsiCo was extremely kind of like low.
Sure.
That's why it had such a short shelf life. And if you were eating that after a couple of weeks, it would be totally fine. But some products are a little bit kind of like more prone to biodegrade than others. So that's why for ketchup, it's a little bit longer, but maybe for like a very fresh product, it might be a bit shorter.
Have you ever wondered, how do I reduce my carbon footprint? Should I focus on recycled content or reducing weight first? Which design strategies are the most effective for my products? Triac offers multiple solutions for lifecycle assessment, goals management, reporting, EPR fees, and more. Visit triac.com to connect with our team and register for a free 10-day trial of Eco Impact Compass to get started today.
Okay. And then that's something that you work with the brand on, obviously. So if it's an alcohol, if it's alcohol based or if it's like vinegar based, all of those different chemicals or all those different compounds are going to act differently with the Notpla.
Yeah, exactly. And that's where it's quite interesting, because in a way, if you want your packaging to disappear for real at the end of life, it means that it has a shelf life. So it means that you need to work with the shelf life of that packaging. So it definitely doesn't make the life of the kind of like packaging of the company that produces this product easier, but it is at the end of the day the burden that should be on the producers to make sure that things don't go the wrong way. So by working out early on what the product can do, that's how we enable these products to kind of go in the market. Don't know where it's going to end up, who's going to put it in the bin, on the ground, eat it, but you know that it's not going to do any harm.
That's awesome, man. And then, so you've gone from that, and then you have coatings. I was looking at some of the coatings that you have available, and so immediately my head goes, stays in food, right? So it would be like a card, like when you buy produce at the grocery store, there's produce in these big cardboard boxes that are coated with either some kind of a plastic liner or some kind of a wax. Basically, it's a moisture barrier. Your product is a moisture barrier also, but then does it also start degrading immediately, like the Ojo?
So the coating is really exciting, and especially because we're literally starting to industrialize like the production as we speak. So we've literally received the first few pallets of boxes completely made industrially in the last couple of weeks. And actually, if you go on our website, you can actually start ordering the boxes directly from our website. So we're quite excited for this. At the moment, the focus is mainly on takeaway food, like delivery, food service, because that's also where there is such a short time of use and such a disproportionate kind of like using plastic. And so the coating is a way to add water resistance and grease proofing to cardboard that, as you said, currently is either done by a thin layer of plastic or some additives that go in the pulp that are typically PFAS. So they are kind of like Teflon-like materials that are starting to be banned, or other kind of sizing agents that are basically petrochemicals that we add into cardboard to make it more resistant to water and to grease. And so what we've been able to do is bring a completely natural way to add this functionality so that the cardboard itself can be completely free from all those synthetic additives, so that we have something that really has a chance to break down. And by removing those additives from the cardboard, we've actually made cardboard much easier for nature to break down. So the same way that an Ojo would break down in a matter of like weeks, the coated board can also break down in a matter of weeks. But the main difference with Ojo is that because the product is not constantly in contact with a liquid, you don't have that level of moisture that would start the process with the kind of microorganisms that are present in the air or environment. So until you have a consistent level of moisture, nothing will happen. And that's cool because it means that we can also ship these products longer distance before we establish local manufacturing. So it's a little bit more a little bit easier to have the normal supply chain that you would imagine for this kind of product. The great thing is that in a way, it's kind of like nature's kill switch button. As soon as you have moisture, bacteria, which you find in the environment everywhere, and air, then things start to kind of like break down. And if you keep it in a supply chain where you don't have like a huge microbial load and controlled moisture, and you're not at 95% humidity, there is nothing happening for years.
So if I'm manufacturing packaging in Indonesia, for example, can I order the coating and apply it there, or I have to buy it coated from you?
So this is a journey that we're on. And in a way, to start driving impact, we thought that it would make most sense for us to make final products, in this case, like food boxes, to create a strong use case and really prove that like these products can work, that we can make something that is completely natural and biodegradable. So that's why we've gone all the way to make boxes and to sell boxes to restaurants, to distributors, and so. But obviously, all we want is to have the greatest impact possible. So there's a couple of ways that we can actually have even greater impact once we convince the partners to jump in on this technology. So one is to buy coated board. So as part of our process, we are coating existing references of cardboard from different manufacturers, and we have these big kind of like ton reels that get kind of like converted into boxes. So we can sell those for people who want to make their own design, whatever boxes they want, and kind of like make folded products. But eventually we would love to work with like paper mills and coaters who can buy directly our coating and they can apply it onto their cardboard or their paper directly. What we found from our experience is that this industry is quite old school. And so it's a little bit hard to convince people to kind of like run super fast, expensive production lines with seaweed material that has like little kind of like proof points. So that's why we're doing all the steps to get it to there. But eventually that's going to be the way to have impact.
Okay, so then if we're talking about working with a paper mill, so they would make the paper, they would apply this coating to it. I would buy it. I would send it to my manufacturer. Now, if I want to get things printed on it or foil stamped on it, that material is going through not the cleanest equipment, and we're talking moisture, with the inks. So at that point, would that then flip the kill switch essentially?
Not really. I mean, we don't have the feedback from hundreds of different converters, but I really think that we can also like confidently solve those issues. Because when you think about it, a lot of cardboard products, they are quite susceptible to humidity and like the environment anyway. So paper is already a material that is quite responsive to its environment, unlike plastic. And so I think that by taking the right kind of like precaution and kind of like testing things, we can really validate a way to work with many different partners. Up until now, we've been able to go through printing process and kind of like still have the coating do its job and doesn't have like the kind of like issues that would be related to going through multiple machines and equipment and so on. So I think that we're quite confident that we're going to have something that fits the existing infrastructure.
That's awesome, man. And then if I've got this coating on my paper, it begins breaking down on the microbial level. Does that then kickstart the breakdown of the paper, making that faster because it's already in the process of breaking down?
Yes. And actually, that's one of the big things that we have discovered. So the way we test biodegradation in a very kind of like honest way, in our office, we have a wormery kind of like bin where we are able to time lapse different materials and see how when we iterate on our process, we are changing the way that microorganisms or worms are able to kind of like turn this back into compost. And it's completely room temperature. It's not an industrial composting kind of like setup at all. And the really interesting thing is that whenever you test cardboard that has sizing agents, so these kind of like petrochemical materials that are added to the pulp, they typically make the cardboard kind of like repellent to water in a way that makes it very hard to make for bacteria to start breaking it down. So by keeping moisture away from the fibers, you're kind of like exponentially making the material more kind of like harder to break down. And the great thing with the Notpla coating is that because it is essentially the building blocks of seaweed, nature has a very easy way to kind of like get in, start to break down those chains and start to basically like turn this into like very simple components. And as soon as this is done for the coating, it's very easy to turn on the cellulose fibers. That in a way, cellulose is kind of like a cotton molecule of the seaweed extract. So it's all kind of the same for nature. It's a polysaccharide and it's very easy to break down. So what we've seen is that more than just breaking down the coating, it's breaking down both at the same time. Whereas on other kind of like board, and even when we've coated board that had sizing agent with our coating, the board itself wouldn't break down very quickly. It would take months.
Wow. So, all right. So then you've got this product. We've got a couple of minutes left. What are you replacing? Right. You're replacing single-use plastics when we're talking about ketchups, mayo, those types of things. Then you've got a coating that can go on plates for moisture barrier. Still in the food industry. And that's a great industry to be in because there's so much waste there. What's next for Notpla? What are we going to have bags? Are we going to have straws? Are we going to have cups? Like how far does this go?
Yeah. So I think that this is where we are super excited because there are so many different kind of like possibilities to challenge like plastic where it makes the least sense with those natural materials. We're very excited about the latest development, which is the Notpla films, which is a transparent heat sealable, flexible packaging that is mainly focused on dry products. And the really exciting thing is of this material is that after quite a lot of R&D, we've been able to make the material heat sealable. So it means that we are able to run through the typical vertical forming, filling, sealing machines. And so at the moment, we're targeting mainly like dry food that is quite kind of like stable. So we're doing pasta, rice. We've even done some coffee sticks that like you can throw directly into the boiling water mug and it just dissolves and appears, because we can control properties like solubility of the film either in cold or hot water. Another application for the film that we're excited about is for detergent like pods, because they currently use PVOH, which is again made from petroleum, and it's a plastic, and so we can replace that with seaweed. And so I think that with films, there is a really good shot at a market that is incredibly vast, but we don't think that we're going to replace everything in that market. We definitely have like limitations. Barrier properties are never going to match exactly plastic because of those reasons of enabling nature to break it down at the end of the day. But a lot of that plastic is actually not really necessary in terms of performances. There's a lot of things that could just do with a film that is transparent, that is holding things together, protecting it from friction and transport and so on. And then you use it and then it's over and you just kind of like let nature deal with it. And that's the stuff that we're really excited.
No, that's exciting, man. And I look at a lot of these brands that are coming out now that have, they've got one container that you purchase and they've got these refillable pods that refill the product. I see Notpla as like a solution for that. When we're talking about fragrances, like perfumes, you buy the bottle, and then getting another version that you can then, squeeze into there. So you keep the beautiful packaging and then you get the refill and you can throw that away without, having all of this waste. Because so many people are using, Tetra Paks or multi-layered films, and it's just creating more waste. It's a different kind of waste, but it's still more waste.
Absolutely. And I think one of the things that has been quite surprising for us throughout COVID is that some of our markets have been quite disrupted. There hasn't been like marathons or festivals for a while, but some of the new markets have really kind of like exploded. We've seen a huge raise of interest from cosmetic brands, and especially from waterless cosmetic brands that are mainly kind of like focusing on e-commerce, direct to consumer, and they know that like their consumers, by receiving things at home rather than picking it in a shop, they're going to receive just so much more packaging. So the packaging really needs to fit those requirements that the consumers have in terms of having lower environmental impact, being exciting, and really telling the values of the company. And so because I think cosmetics has typically a higher kind of like margin and a higher value perception, there is a lot more innovation that is happening in that field, and especially in direct to consumer. So we're super excited to start testing things with a number of companies on that front. And I think that also with the push of removing as much water as possible from cosmetics, either that you remix yourself at home or products that didn't need to have that much water in the first place. There is a quite nice fit with the films, for example, where we can provide still a transparent packaging that lets the consumer see what's inside and understand that this is the product that you want to kind of present, but at the same time that is creating zero long-lasting waste, that is literally the most sustainable packaging you can get right now, and that is also kind of doing its bit and showing that we can really change the way things are working, and that if you're not creating a long-lasting waste, you can be you can be a little bit more kind of exciting in that unpacking experience. It's not about reducing by 30% the thickness year after year. You can create things that are not wasteful, but that are kind of more exciting and more in tune with nature.
That's awesome, man. So Pierre, thank you so much for being on. I really appreciate this. If anybody wants to get a hold of you, if anybody wants to learn more about you and Notpla, what's the best place that they can find you?
So if you want to get in touch, don't hesitate to send me an email. It's pierre@notpla.com. But otherwise, you'll find all our contact details on notpla.com, the website.